Hi, so I'm Edouard Ligon, I'm the founder and CEO of QuasarDB. QuasarDB is a time series database, so I have 10 minutes, right? So I want to spend as much as 10 minutes doing the demo because we're doing some data exploration live on this laptop I bought 3 years ago on 50 gigs of data, real time. Can we do it? We'll see. I have no idea. I made a program this morning. So what's QuasarDB? QuasarDB is a company I started roughly 10 years ago when I was working in finance. As you can do the timing, 10 years ago was not so great. And I have absolutely no knowledge of database back then, and I was very naive. I said, well, we have 1 petabyte of data. Why can't we create that in real time? So my idea was, yeah, okay, so we have this some technology that is relational databases, but we need custom database more and more because this amount of data, which is insane, cannot be processed in real time if we have a generic solution for it. Doesn't mean the generic solution is crap. It means you need something custom. When do you need something specialized? Don't want to spend too much time about it. Usually it's the volume, latency, or sometimes just convenience. A good example outside of time series, graph databases. If you have a problem that is really easy to reason about in graphs, it just makes sense to have a graph databases. For time series, it's really when the question that comes very often is when. When did I get this value? When is my sensor that value? When? And auctions. So what are auctions? Because actually stock exchanges work as auction houses. And auction is really when did you win the bid? So QuasarDB has 2 kinds of customers. I would say 80% is finance, hedge funds, investment banks. And we have more and more industrial IoT because these guys say, oh, well, we have a lot of data. What are we going to do with it? Well, financial markets, problems. So 2 terabytes of data incremental every day. You want to keep that forever. So I will let you do the math when it's 10 years, 20 years. Easily 1 petabyte. 2 terabytes is roughly North American market only. Yeah. Entitlement. So that's something that may not be super interesting for the demo, but it's a very big problem. You have 1 petabyte of data. Not everyone can see it. And also some data is much more expensive than some other data, especially the data real time. And as a bank, you don't want to be charged for everything, just for a couple of users. And then the other thing we want to do is break down the data silos. So sorry, I'm going very fast because I want time for the demo. Feel free to buffer up and ask questions later. So Quasar is really a distributed time series database. It resembles in terms of interfaces a relational database. We kind of, oh sorry, went too fast. We give you a SQL interface, but it's not a relational database. Why SQL? Because you already know it. So some benchmarks. So there is 1 database missing here, KDB. We can't, for licensing reasons, show a benchmark of KDB, but don't worry, we do well. So I showed you some benchmarks. You may want to see what's up with that. Is it large enough? Can you see it? Okay, cool. So I have a table. Actually, I saved all the queries because, you know, demo effect. So this is a table. It's a kind of transaction log. Please bear with me, just a demo. I know a transaction log for deals is not that way in finance, but nevertheless. And how many data do we have? Oh, sorry, it took 1/2 second to count. 2.5 billion rows. It starts from 2008 until 2016. It's generated data, of course, and we kind of generated transactions like we have traders. They are kind of doing transactions, selling products for a certain price. And let's say we are the head of front office. We want to see what's up. And we want to, in theory, what's going to happen if we were in real life, it would not be queries, it would probably be on dashboard. But the dashboard on the back end would do the queries. So what I did is I typed a query just to say, hey, just give me the sum for every year of the transaction I have and the average price. So as you can see, it took roughly 1/2 second for Quasar to do all the aggregation by the year. And you can see we have some extensions around SQL to make it easier to do time-related queries. Because the problem with SQL, if you want to say, I want this year, and then you end up with a very, very large workload, it's very annoying. So we just say, OK, we keep SQL, just add a little bit of touch here and here to make it work better. So if you're a bit careful, you can see there is something a bit odd in 2012. Let's zoom in a bit, okay? As you can see, I just type month and years, and Quasar has an understanding of the calendar. So I don't have to tell him, hey, by the way, this year is a leap year. No, it knows about all of that. And you don't have to type it. So again, well, something is really up in April 2012, right? The sum is really higher than it should be. So let's zoom in a little bit more and have it something by the day. And so it did the query. So what happened is it took the data from disk, decompressed it, put it in memory, did the aggregation, all of that. It's on the disk. It's not in memory. That's why it's slow. Because if I do it again, it's going to be instant. As you can see, there's something really weird in April 4. And that's really typical. To be very honest with you, what would happen is this would be probably called by what we call pre-deal check. That's a system that happens before I do a deal. Because what we're going to see is that we can aggregate by agent. And if I look by agent number, someone did a very high numbers of deal at that time. And we can do some convenience. I'm going to show you some joins we have built in with Quasar. So here we have an ID number. I just did a join to have a name. We have a lot of joins. So you know, database is really about how many joins can you do. With Quasar, we have a lot of them. So let's look up a little bit more. What I'm going to do is I'm going to do some basic stats. I'm going to do the average volume since the beginning of time. It's around 500 per day. 500, okay. And now we're going to say, okay, what if I have, what do I have? Let's find a query, sorry about that. So I could say, okay, what do I have one order of magnitude larger than that? Because 10%, 20% doesn't mean much. So we're going to do a scan of the data in real time. 1.5 billion rows per second on this. Pretty good, right? And we can see we have 94 transactions that are erroneous. Then I will have, what is my final query somewhere here. Yeah, I just say, yeah, that's the final query about all the stuff, and then I just display the erroneous transactions. So yeah, it's a bit nerdy, sorry about that, but I wanted to showcase the power of the database, and I was thinking about what can I show to do that. Well, let's see what a laptop can do with billions of rows, right? That's it for the demo. If you have questions, I'm all yours. No question?
So you were just able to show 1 billion rows. Are there scaling limits as you go to the enterprise use case that's not on a laptop?
No, the database is scale out. We scale up on CPUs, and we scale out on nodes. We have a use case with 20 terabytes of data per day. Well, I'm not going to say no problem, because it's absolutely not no problem, but we can do it, yeah. Yes?
I'm sure the demo is above a lot of people's heads technically, but is this normalized data that you are working with or no?
So the question is the data normalized? For this demo, I wrote a generator. So the data is clean, yeah, as clean as you can get. We have tools when you insert the data into Quasar to help you clean up. But we don't have a miracle solution to the data cleanup problem. We really are there to solve you once you have your data a little bit normalized. We can help you in the sense that you can have it in different tables. And then with the joins, maybe can help you, find the right data with the right timestamps, that kind of thing.
So this is not a general purpose database for inserts, updates, and deletes, but mainly to crunch large data sets for data science and machine learning, I assume. So
the question is, it's really a database organized for research and data crunching. Yes, but it really is very, very good at data ingestion. It has really no ingestion limit. We solve this problem because the model we're selling to some of the banks I cannot name is we plug the streams direct from the markets inside a database, and they can query it. And this has enormous value because then you have almost no latency between the market and the analysis. But yeah, then it depends on your architecture, right? Yeah, sure.
Can you talk a bit more about the joins? Like, are they time aware in the sense that they do some kind of a look back, or like in pandas?
Yeah. So it's a great question. So pandas has a lot of joins. We have as of join, which is works like the last of pandas. It's a default, and we have a great integration with pandas, where you can get the data inside pandas, and actually Quasar is going to output the data in NumPy format. So you have the columns, and you can also put it back. So there is some advanced stuff you can do in pandas we cannot do. No problem. You just get just the data you need inside Panda, and that's it.
Working with Meg, so you're also working in IoT?
Yeah, yes, we do. Yeah, the question was, we work with Bank and IoT. It's the two markets we are there. Yeah, we do.
Do you support a strong consistency?
So the question, do we support strong consistency? Not only are we consistent, but we are also transactional. We have built-in multi-version concurrency control and atomic transactions on multiple keys. We do that, we require atomic locks. It's based on atomic locks.
All of the queries you run is a derivative action, right? So the derivative type is much slower than shorter.
So the question is, so if I update, then I will wait for the full replication. So yes, that may incur lag. So you should not have a cluster across multiple geographic zones. For this setup, we would advise to have one cluster per geographic zone, and then asynchronous replication between clusters.
Okay, what's the difference between AWS Kinesis, for example, when it expects you some data and after I can run queries output this data?
Sorry, can you repeat?
What's the difference between a database and, for example, AWS Kinesis streams?
AWS Stream? So I'm not really sure I get your question. This is a distributed time series database, so it has built-in aggregations. I know AWS has a time series database, but it's really oriented for monitoring. I don't know if you can do the aggregations you can do, because I haven't shown you everything you can do. Happy to talk about it in more detail with you if you're curious. Okay, time for one more question. Yes? Okay.
How many hosts are you scaling out to? And also, what is the penalty in terms of index creation?
Okay. So the question is related to how far can we scale out? And the other question is, what's the penalty into index? So one great news is scaling out has no impact on index, because we have a specific design where the index is actually shorted at the beginning. So every node is indexing for itself. And we have a built-in clustering mechanism that takes care of that. And for the limit in terms of node, so just one laptop is already delivering a lot. So no problem with up to 100 nodes. But honestly, we have customers with 10 nodes that can already crunch a lot of data. So happy to, if you have a challenge for us, happy to take it up. Thank you. Okay, thank you.